My name's Callie, I'm the Okayest Engineer. In today's video, you get a chance to win a carbon fiber seat. I get a new toy to play with, which I'm super excited about. And finally, we got to jump into CAD so we can design some cool parts for this helicopter. All the information you need to win this carbon fiber seat is at the end of this video and in the video description. There's no purchase necessary, it's completely free, so please stick around to check that out. Now without further ado, I know most of you are here to actually see helicopter content, so let's get into that. If you build this helicopter to composite FX specifications, when you're finished, there's nothing covering the rear end of this helicopter from this bulkhead aft. That leaves the engine exposed and kind of leaves, in my opinion, an abrupt end to what would otherwise have been a very beautiful design. And so that is what the next big project for this helicopter is going to be. I'm going to design and manufacture a rear cowling that will eventually be made out of carbon fiber. And that was the sole purpose of me trying to create my first carbon fiber seat, was to learn the process as opposed to just creating a good seat. I can't start doing any design work on the engine cowling until I have a proper CAD model that represents this fuselage in the computer so that my engine cowling will properly mate up to my fuselage when all of this is finished. And in order to do that, we're going to 3D scan the body. But before we can 3D scan the body, I need to get the fuselage to a state where it represents the final assembly so that once all of this is done, the cowling still fits after all the fabrication. We gotta get the boom off these strings and permanently mounted to the fuselage with the provided hardware. So let's get into that. So I was getting ready to mount the tail boom to the fuselage, and I noticed, I'm not sure if you can tell, but I noticed that this is a pretty uneven surface. And then I noticed that there was some kind of excess, whatever, composites there. And then I looked over here on this side, and this is all pretty uneven too. You can't really tell by the picture. So I thought about dressing both sides before I put together. But then I realized the boom and the fuselage is a matched set. So I called around. It turns out they put the boom and the fuselage into a jig, so it's aligned perfectly. Then they get it close. They fill this gap with, I'm assuming is some sort of epoxy, let it set, and then the boom and the fuselage is perfectly aligned. They must use some release or something to get the two parts apart, and then it fits together perfectly. Pretty sweet. So what you're looking at here is the, I'll call it the bell. This is the fuselage side, the bell that connects from the fuselage to the tail boom. And so to hold the tail boom on, the directions are basically instructing you to create these studs that will eventually go through both the fuselage, the tail boom, and then have a captive nut on the other side. It calls out for AN3 hardware. This is not a AN bolt. This is just a cheap bolt. I didn't want to ruin these. But it's a 1032 bolt with the AN washer, and it goes through here. And what you'll notice is it doesn't actually fit or go flush with the fiberglass. And that's okay. I would be shocked if you could create a fiberglass structure that had a nice machined surface. So what they call out in the instructions to do is use JB Weld to make like a conformal washer or something. Basically, you build up some material so that your bolt will have something flat to compress against. Which I'm totally fine with that. JB Weld is great. It's got a high compressive strength. I mean, that will structurally, it's going to be more than sufficient. But basically we're doing similar to what they did from the fuselage to the boom, is you're making like a matched pair for every one of these 18 bolts. So what we're going to do is we're going to spray the 1032 bolt with a whole bunch of WD-40 to lube her up. And then we're going to lather on some JB Weld to the washer. And then we're going to put it through this hole. And I want to be careful. You'll see if I pull it too hard, there's like a moment on the washer and it'll get all cockeyed. We don't want that. That's bad. We'll be in the same spot we are now. And so I'm going to try and do it very slowly and lightly so that when it gets pulled just barely tight enough, the washer's still flat up against the bolt, and then you're creating, once again, that delta, you're filling that void with JB Weld, and once it cures, I'll have a nice flat surface to secure the bolt to. So that's next. I got to transfer the bolts to the bolt holes to the fuselage. So we'll drill all those, and then we'll start laying in all those pieces or sections of JB Weld, and we should be good to go. The tail boom came with 2 of the 18 holes completely drilled through for locating purposes. The rest of the 16 were only partially drilled through and had to be finished by hand. Ideally, you would just mount the tail boom and then match drill the holes to the fuselage, but these holes are way too close to the actual boom, and I can't get a drill or even a 90-degree adapter to get in close enough to drill it. I'm using a marker to transfer the center of the holes to the fuselage, and then I had to get a little creative on how to accurately transfer those holes to the fuselage. So right now you can probably tell I'm low. It looks like I don't even have the angle right. It's pointed up. And so for the next one, I know the mating hole right at the face of the fuselage is good. So I think I just need to point it a little more level. We'll shoot it in and we'll see how the next one goes. So I'm using the existing drill bit to tell me what angle I was at. And then I can pull it through the front side while holding everything tight. This may sound janky and weird, but just roll with it for a second. I'm going to give it a little bit more up. Left and right was fine. And we're going to thin that one in. We'll leave it in there. And we'll see how it is. That drill bit is better. It's still a little bit down. So I'm still a little bit at the bottom of the hole. So we'll point it up even further and keep going. And we're just about perfect now. I think it still might be just a hair down, but pretty close. We'll step it up one more and see what happens. That is pretty dead on. Just about perfect, actually. So we will open that up one more, and that'll be the final size. And there it is. It's tight, that's good. But yeah, as you can see, that is way better than I started with. And that method works pretty okay. So we'll do that for the rest of them. It's gonna be tedious, but I'd much rather take my time and do this right than to have to start replacing big parts. That'd be real bad. And I repeated this process for the rest of the 18 holes. I got a little lazy and started doing 4 at a time, but in the end, it all worked out pretty well. All right, so we got all the bolts in. Let's see if she'll support her own weight. And there she blows. Look at that. So right now I only have the bolts temporarily in. They're only torqued to, I don't know, maybe a couple inch-pounds. This is the wrong hardware, the wrong everything, but I needed to get at least the boom mounted so that I can take out probably like 4 at a time and make those, I guess, conformal washers that I talked about earlier. We're going to use JB Quick Weld to do that. This sets in 6 minutes as opposed to the other stuff that sets in a couple of hours. I was worried using the regular stuff and then having the chance of it running down and actually not creating those washers that we're trying to make. So this should do a little bit better. I'll do in sets of 4, that way I don't run out of working time. And then the other one, so this is slightly less strong. This says it's good for 3,000 PSI. I think the other stuff is good for 5,000 PSI, so not very much drop in strength. And these only get torqued and I don't know, I'll have to go look at the manual, but I think it's like 10 inch-pounds. These are nowhere near the strength or need the requirement for even this, so this is way overkill even at that. So I'm okay with using the less strong epoxy. It's way overkill for what it is, and then now we'll get into actually making those conformal washers. All right, so I've taken my first 4 bolts out. These are, I'll call them my first victims. The hardware on the left side, this is the trash hardware. This is just what I'm using to basically make these conformal washers. The hardware on the right, this is actual AN hardware that will be used on the helicopter. This is a scrap one, so I actually won't be using these. They'll be new. But basically, so these are the AN washers. A -8 happens to be the exact same size. So you can see here that they're pretty much equivalent. Once again, I'm just preserving my AN hardware so I don't screw it up with this process. So we'll put a trash washer on a trash bolt. We're going to end up lubing it up with some WD-40. This is just to give a barrier so that the JB quick weld does not adhere to it, so I can actually get these bolts out. You'll notice also that these the trash hardware is threaded completely, where the AN hardware has a shoulder. That's actually gonna be just fine too. I think I'm gonna have to drill these out one more time once the JB weld sets. So that'll give an even better fit for once we get the shoulder bolt in. The JB weld will fill in the voids within these threads, leaving extra material, and so that extra material is what I'll be post drilling out so that we have a tighter fit for the AN bolt. So yeah, right now we'll prep these by spraying them with a whole bunch of WD-40, and then we'll go throw it into the bird and see how well this works. So this is a comparison between the 2 washers, and for those of you that don't know, there's actually kind of a side, I'll call it, to washers. You'll see this side has a nice like beveled edge on the ID and OD, and it's kind of a little bit of a rounded face, and then the back side is almost a perfect face, and you have a much sharper edge. So sometimes you'll put this one way or another depending on what you're doing. If you want to save your paint, you don't want to leave a really nasty line. Some people put the flat edge or the softer edge towards the paint, and that gives your kind of nut or bolt something better to sit on. In this case, I'm going to put the flat face actually on the trash washer. I'll put the flat face towards the fuselage so that when the JB weld sets, I'll end up with a much flatter face to put the hardware up against. So we're going to use the much flatter, much sharper edge once again towards the fuselage and see how that sets up. And my first attempt at this, I thought it might be better to put the bolt in the hole and then try to smear in the JB weld. And you'll see here it worked, but it didn't work that well. So after some of the learnings here, I made an attempt and did something different. So after a little bit of trial and error, I found out it was actually easier and better if I just placed, oh, I'm getting out of view, sorry, hard to do in video at the same time. But I found out it was better to place the JB weld right onto the bolt. And unfortunately, the WD-40 makes it super slippery, so it doesn't stick that well. But that way, once it's on the bolt, it'll basically like mushroom its way out when you push it into the spot. So let's go see how that goes. And once again, you can see here, we're just putting it in enough so that that JB weld mushrooms out and gives me a nice surface for that bolt to sit on. Pretty good. And the conformal washers are pretty much finished. Some went better than others, but for the most part, I think it's going to be just fine. I'm not going to pull this hardware out right now and replace it with the good stuff yet. That's going to be further down the road, and it really doesn't matter. But for now, The boom is mounted and it's unsupported, it's fully fixed. And now that everything is in the correct location, we can do a full 3D scan, and it should hopefully match what the helicopter will be in the future. And to do that, we're going to be using the Einstar 3D scanner by Shining 3D. And although it's been out for a couple of years now, it's still, in my opinion, one of the best 3D scanners for scanning large objects for under 800 bucks. The next level up, you're spending thousands, and that's just way too far out of my budget for what we're trying to do. Now, I have made a few attempts at scanning the fuselage with this, and to be honest, I fumbled all the way through it. It was a disaster. I was going to attempt to throw it in this video, but I decided it's much better that I just start on something small, film it after I've actually figured out how to use this thing, and then give you guys what I would call an informative video that actually could be useful. But all the stuff that I've currently done is totally useless and was a complete disaster. We're out of the basement and up in the office for the next couple steps of this process. I was able to get a scan of the helicopter, although I didn't intentionally scan the entire thing. Scanning something this large is massively computational heavy and takes a boatload of space on my computer. And because I'm running the lower, I guess, requirements of what is needed on the computer side, an M1 chip, and 16 gigs of RAM, I was extremely cautious on trying not to get too big of a scan. The output of the scan is basically hundreds of thousands of points that generate a cloud, and that's kind of what you can see here. I was pretty skeptical of how accurate the scan was going to actually be until I was doing some post-processing and stumbled across this feature. I couldn't see this feature with my naked eye, and I honestly didn't think it actually existed until I went down and cast a shadow on the backside of the fuselage, and sure enough, that was there. Insane that it was able to pick that up. But before we get too far into the scan data, let's first go over how I generated this model in the first place. So Composite FX has a drawing on their website that shows a front, side, and top view of the helicopter and gives general dimensions. So I was able to take that drawing and scale it to what the CAD would represent, and then I just started drawing sketches on that drawing. I started with the side, generated as many sketches as I could, and then followed the same philosophy with the front and the top view. After a massive amount of work and hours spent, I generated the model that you see here and was actually pretty happy with how it turned out. Naturally, the next step was to import the surface model that I generated from the scan to see just how good of a job I actually did. To my surprise, I was actually pretty close. Stoked that it turned out as good as it did, but this is not nearly close enough for what we need to generate a model of another part to mate with the fuselage. So here we go again with a massive amount of more work, altering all of those sketches and massaging the current CAD model into something that more represented the scan. The red surface you see here is the scan data, the scan model, and it's infinitesimally thin. So anytime you see red, it means that the surface is outside of my model. And then anytime you see any other color, it means it's sitting inside the model. So I had to massage the model out to meet the scan data. And you can see now here, after it's been all fixed, that the red and the blue kind of intermeshes with each other, and that is because that very thin surface is so close to the actual modeled surface that it's going in and out of the surface quite frequently, even though those contours are very close to being the same. Now that we have a good model, we can now start to design the part. It wasn't until right now that I realized I never actually gave anyone an explanation as to why I'm making these modifications and backing it up with any sort of data. So I want to do that now. It's going to get a little technical, so I apologize for that, but please hang on. I think you might learn something, and I think it'll answer some questions. So there's two main reasons that I'm putting this cowling on the back of this helicopter. The first of all is obvious. It's for the looks. I think it's going to make this helicopter look way better, and I'm excited to do it anyways. But the second one is obviously way more important, and I want to get into that. So A bunch of pilots have noted that when they put the doors on, you can buy doors for this helicopter, and when they do put those doors on and take it for a flight, they've noted that the helicopter gets a little bit less stable. So let's jump into that. The reason it gets less stable is because, or I guess to define how stable something will be in flight, is governed by the distance between the center of gravity of that object and the center of pressure. So for example, an arrow from a bow and arrow, it has tail feathers because that extra surface area way rear on that object moves the center of pressure pretty far back. And now that center of pressure is aft of your CG, and that's why arrows track so straight. So now let's transfer that into how it correlates to the helicopter. When you put the doors on the helicopter in the front, it does two things. You're adding surface area to the front of that helicopter, which is moving the center of pressure forward than without those doors. It's moving the center of pressure forward, closer to the center of gravity. It also does a second thing that's not good. When the doors are off, air enters the door and it actually hits the wall behind the pilot in the cabin, and it creates drag on that side. So if I'm tracking to the left, air enters on the right, it hits the wall on the right, and then it tries to correct that out of track just with drag. It's inherently stable in that way. And so you're losing that drag and you're adding forward surface area, transferring the center of pressure closer to the center of gravity, and it makes the helicopter slightly less stable. So to correct this, I'm building an engine cowling that's extra surface area that's going to go aft of the CG, and it's going to push that center of pressure even further back, which should and hopefully create a more stable helicopter and make it track straighter. So outside of just hunches, which are basically useless, I needed to go get some actual data to back up this theory that I had. So I jumped into CFD, which is Computational Fluid Dynamics. It's a plugin for SolidWorks, and basically tested it. So I took a couple different configurations, the first of all being a standard composite FX helicopter without doors to see a baseline. Then I did one with doors, and then I did one with the cowling and doors and compared those results. It's also important to note that I think I put either a 10 or a 15 degree, I think to the left track, so that the air wasn't just going straight down the body. I wanted to see what would happen in the event that it was tracking incorrectly. And so long story short, I got all that data back, and the results actually supported my assumptions. Having a rear cowling on the helicopter made things better. It tracked better, it reduced the overall drag. There's another thing called nose tuck for these helicopters, where just as you speed up, it gets more drag, and a semi-rigid rotor will actually push the fuselage back, causing the nose to tilt down. That's a huge reason why some helicopters have tail or horizontal stabilizer. It's to push that nose back up. So anyways, it makes all of this better. And so I don't want you to just think that I'm haphazardly throwing parts on this helicopter and not thinking them through. There is a lot of engineering and a lot of thought that goes behind each and every one. And my ultimate goal is to make this helicopter better, to make it safer, and to have a really good time. Now that that's out of the way, let's jump back into CAD and see how we're making these changes and getting this helicopter to primarily just look cool. So as I mentioned a couple times, we're trying to incorporate the MD500 type of teardrop lines into this helicopter. And for that, I did the same thing. I imported a side picture of an MD500, and then used those lines to inspire the shape that I was developing. You can also see here that the front portion of the composite FX fuselage has this contour from the bottom that is just the wrong shape. It would put the back end of the teardrop far too high and far too forward for the look that I'm going for. And so I needed to extend that down and basically create my own new line from the bottom of the fuselage that would more match and mimic what that MD500 would. And so that's what you can see I've done here. Covering the engine and enclosing the back of the helicopter incorporates its own new set of challenges. It will reduce the amount of airflow that goes over the engine, and that whole area will go up in temperature slightly. So I thought it would be a good idea to incorporate some scoops or some inlets to the top of that fairing that would help draw air in through the top. If you may or may not know, this is a water-cooled engine. There is a radiator that sits at the bottom, and so that radiator fan will blow air down, and it will help induce airflow through that entire fuselage while the helicopter is hovering or in flight. I think, and I'm going out on a limb here, I think these scoops will be sufficient. We won't know for sure until, unfortunately, this whole thing is built and I have time to test, but I'm going to just chalk this one up as hopefully it's going to be fine. We've seen how that's gone before, but I do think we're going to be okay. And worst case scenario, we'll come up with another solution if we run into a problem down the road. So I need to clarify a couple things here. I'm not worried about the engine overheating. This is a water-cooled engine, and the radiator and fan, that is their primary purpose, and the amount of cooling you get just by radiant heating or convection heating off of the actual block is basically nothing compared to what you get out of the radiator. As long as your thermostat is not fully open and you're not at the limit of your cooling system, putting a blanket around the engine is going to be basically a non-issue. So cooling of the engine is going to be fine. I'm concerned about heating up the composites which surround that engine and getting all of that hot. So the tail boom getting warm, or this newly designed rear engine cowling, if that gets too hot, those can degrade over time, and that is definitely not what you want. You don't want any failures happening in your composites. So that's what I'm mentioning when I say I'm concerned about things being too hot. It's not the engine, it's the actual composites. And finally, the last thing to do here is to take this new design and transfer it into something that we can actually use and produce to make a mold. So that's what you see here. I've split this section into 4-inch heights, and they're stacked up throughout the entire length. I'll then take those 4-inch heights, put that into a CAM software, and we'll machine each one of these segments out of foam to be assembled back together in a later video, making that whole plug, which we can then mount to the helicopter and then start producing a mold from that. Now, quickly back to the seat. You may be asking yourself, Callie, you just worked so hard to make that carbon fiber seat. Why are you giving it away? Well, unfortunately, the seat doesn't actually fit. It fits physically, but in this helicopter, which I don't have yet, there's a collective lever on your left thigh. And that collective lever has to be able to pull up, so obviously you can raise your collective. Unfortunately, this seat, the front portion, the bolsters near the thighs, are far too wide to allow that collective lever to go up. I could cut the seat up and make it work, but that would leave a relatively sharp kind of edge, and it would just frankly bug me. So I would rather go through all that effort again to make the seat right and to make it something that I would be proud of. So that's what we're gonna do. And because it doesn't fit, that gives all of you a chance to win this carbon fiber seat. All right, so what is this carbon fiber seat and how do you actually enter to win? So you can see how we made this seat. I'll leave a link up here back to the build series where we went through the entire process to making the mold and making this carbon fiber seat. So please go check that out. This is 4 layers of carbon fiber. There's no core or support material. It's pretty strong, but it's not like super strong. I was going to finish this with some core material and then put some mounting brackets. Obviously this has none. But once I found out that it didn't fit, I put a kibosh to all that extra effort. So I guess for legal reasons, you shouldn't use this seat. It shouldn't be put in a car. You're going to have to make some mounting brackets if you want to. You can basically do with it what you want, but I'm releasing all liability. It's pretty much just a beautiful seat, and I hope you guys put it to use for something. But anyways, you enter to win by purely making a comment in the comment section of this video. This giveaway will run until January 31st at midnight Eastern Standard Time. At that point, it's closed. There's only one entry per person, so multiple comments, though appreciated, won't actually increase your chance to win. I would say go subscribe, but I feel like I have to earn that. I can't ask for that, so do with it what you will. The only requirement to enter this giveaway is to make a comment in this video. I have to limit the winning to the continental United States. So Canada, Hawaii, and Alaska, I'm sorry. And I know a bunch of you viewers are overseas, but I apologize. I'm not going to be able to do that either. But once again, enter a comment to win. That's all you have to do. Shipping is free. I just want to give this to one of you guys who helped me get here, and I appreciate the support each and every one of you have given me. And that's going to do it for this one. Thanks for sticking around. Here's a sneak peek as to what you'll get to see next week. As always, go build something cool, never stop learning, and we'll see you on the next one.